Welcome back, Focus Learners. Let's just dive right into today's explainer. We're going on a bit of a journey today, moving away from the Wild West of manual Azure infrastructure, which we affectionately, or maybe not so affectionately, call ClickOps, all the way to the highly structured, version-controlled utopia of infrastructure as code. If you've ever stared at a massive cloud environment sprawling across multiple regions and thought, how on earth do I bring this under control? You are in the exact right place. We're going to break down how to corral all that manual chaos into a predictable, automated pipeline.
And that brings us to the massive headache we are tackling today. How do you actually turn existing Azure resources into Terraform code? Look, we all know that unmanaged, legacy cloud resources are a huge liability. You want to manage them with Terraform, obviously, but writing that code from scratch to perfectly match a live, complex environment? Yeah, right. That feels near impossible, not to mention a massive drain on your engineering hours. So how do we pull this off without breaking everything that's currently running in production?
Well, here is our roadmap for today. We'll hit the legacy cloud problem, native Terraform import, Azure export for Terraform, generating your code, building the DevOps pipeline, and finally, safe, automated deployments.
All right, kicking things off with Section 1, the legacy cloud problem.
Here's the brutal truth. You've got legacy infrastructure sitting there live in Azure. It might be running mission-critical apps or core networking, but there is absolutely zero code to track or replicate it. When you manage infrastructure manually through the Azure Portal UI, every single change induces total anxiety. Who clicked what? Why did that firewall rule change? Without version control, you have no audit trail and no easy way to roll back. If we want the stability of infrastructure as code, we absolutely have to find a way to import these resources.
Moving right along to Section 2, native Terraform import.
So native Terraform import is the standard built-in solution for this. It's a process that reads your live resources and writes them to a state file or a generated .tf block. But look, it's not exactly a magic wand. Cloud services are super complex, and as HashiCorp's own docs point out, each remote object has to be imported to exactly one resource address. You really have to perfectly align your local state with reality, and that gets messy.
You really feel the pain of the native method when you look at the steps. First, you have to write a bare-bones skeleton resource block. Second, you run the Terraform import command targeting the resource ID. Third, you run Terraform plan. And fourth, you're stuck in this endless loop of trial and error, copying and pasting missing attributes from the plan output, running the plan again, finding more missing attributes, and repeating. If you've got hundreds of resources, this is literally going to take you weeks. Nobody has time for that.
Thankfully, we've got Section 3, Azure export for Terraform.
When we compare the native method with this tool, the difference is literally night and day. Forget that tedious skeleton block. Azure Export for Terraform, which you might remember as Azure Terrafy, acts as a full clone. It automates the heavy lifting by generating both the HCL code and the state file for you, completely automatically. The tool interrogates the Azure API and writes the entire resource definition out for you.
Now you might be thinking, hey, why not just hit the export button right in the Azure portal? Well, check out this number, 1,000. The Azure Portal's export feature actually hard caps you at 1,000 resources and a tiny 4 megabyte payload. Plus, it just drops some resource types entirely, giving you a totally incomplete picture. The AZETF export CLI bypasses all of that nonsense, giving you a complete export of your live environment.
Let's get our hands dirty in Section 4, generating your code.
So if you're sitting there thinking, show me how to create a Terraform file from my Azure DevOps environment, well, the first step actually happens here in the CLI. Step 1, you install the tool via Go or Wingit. Step 2, you run it against your target resource group. A really brilliant pro tip here is to append the --HCL only flag first, just to verify the configuration without permanently impacting your state file. Step 3, you literally just press W to execute the import. Finally, you review the generated main.tf and state files. Boom. In minutes, your environment is codified.
But let's be real for a second. No tool is absolutely perfect. It dumps everything into a single main.tf file, which is a total nightmare for readability. The scope is just limited to the resource group level, and crucially, all the values are completely hard-coded. You're still going to have to roll up your sleeves and refactor this raw code into reusable modules with actual variables so it scales. It gets you 90% of the way there, but you are still the engineer who has to clean it up.
Now for the really fun part, Section 5, building the DevOps pipeline to manage all these new files.
Once you have that code, we absolutely do not want some wild auto-deploy on-push setup for critical infra. We need enterprise-grade safety. We're talking federated OIDC service connections, so no hard-coded secrets that expire and break your pipelines. We need human stage gates for approvals, reusable YAML templates you aren't copy-pasting messy code across projects, and a highly secure Azure Blob Storage remote backend.
And here is a massive pipeline technique you need to implement: dynamic state file naming. Don't hard-code your state file names. Generate them dynamically during the pipeline run. Something like project_environment_region.tfstate. This means you can reuse the exact same pipeline YAML across dev, staging, and production without ever accidentally overwriting a state file. It's a huge time saver.
Let's wrap things up with Section 6, Safe Automated Deployments.
This timeline right here is your ultimate safety net. First up, parameter validation. The pipeline instantly fails if the user didn't explicitly select an environment and region. Then it runs validate and plan. After that, it literally hits the brakes at an approval-gated stage. It pauses execution completely until a real human reviews the plan and hits approve. Only after that verification does the final apply actually run against the cloud. And here is the ultimate payoff. When you run this newly generated refactored code through your pipeline, the plan output is going to give you this absolute beauty of a quote, "no changes to the infrastructure." Seeing that proves beyond a shadow of a doubt that your new code perfectly matches your live environment. You've officially wrangled your unmanaged legacy infra into strict version control, securely linked to an automated pipeline.
So, the big takeaway today is that migrating legacy resources does not have to be a ClickOps nightmare of guesswork. The right tools do the heavy lifting, letting you focus on building robust pipelines natively in Azure DevOps. Now that your legacy infrastructure is fully codified and you're finally free from manual management anxiety, what are you going to build next? Thanks for hanging out with me on this explainer. Focused learners, keep building, keep automating, and I'll catch you next time.